All right. All right, we're going to continue with logarithms and equations of logarithms. So let's try two to the 3x plus 1 2 to the 3x plus 1 is equal to 3 to the 4 minus x. Alright, solve that one. Now, whenever you have one like this, because most of you are going to sit there and meditate, unless you've had this before. Whenever you have a number raised to an exponential variable, the best thing to do is take the log of both sides. So go ahead and write that down somewhere and highlight it. Take the log of both sides. Now, once you do that, you can do something else. Definition of a logarithm, maybe? Or you might could rewrite this and do what with these two exponents? From out front, Now I can tell you right now, if you have 10 problems on a logarithm test, 8 of them are going to be solving equations. So if I give you 20, that means 16 of them are going to be solving equations. So you better get used to doing this. So, using your power rule, 3x plus 1 times the natural log of 2 is equal to 4 minus x times the natural log of 3. Now, I'm not going to write it like that. I'm going to write it like this. Now, why did I write it like that? Distributed. Because the natural log, or the LOG of a number, is the same as a number. It's going to be a number. So that's just like having a 4 and a 5 in front of parentheses. You distribute. So you can either turn it to a decimal or you can distribute it. I'm just going to distribute it. Now some of y'all may look at that last line and go, ooh, I don't like doing that. And you might want to get out of the major that you're in because you're heading for a lot of it in Calc 1 and Calc 2. You cannot limit yourself to thinking that you can just distribute a number across here. You better get used to distributing logs. You better get used to distributing the square root. You need to get used to distributing anything that's in front of a parenthesis.
What is log?
It's a glorified exponent, basically. It's an exponent on steroids, or vitamins, or whatever you want to call it. Well, you use it in engineering. It's used in a lot of engineering applications and business applications. Hold on a minute. Where you have an exponential growth. An exponential growth that's even faster than, a growth that's faster than exponential. In other words, an exponential growth, I showed y'all at the beginning of the section. F of x is equal to x squared. That's an exponential growth. Like that, right? Okay? Well, when you're talking about a logarithmic, you're talking about or the log y is equal to log base a of x is equal to a to the y is equal to a to the y, or is equal to x. This right here, which comes from this, is like, it's a whole lot faster than this. So you're talking, I can't think of an application right now in engineering, but you're talking about strength or the decay of something that decays really fast, then it would be like this, where a regular exponential function would be like this. In other words, it's not as steep as this. So a logarithm is a exponent basically dividing. Okay? Does that make sense?
Yeah. I mean, I've seen our boss, he's an engineer.
Mhm.
He does stuff like he'll do all this calculations and stuff to figure out, A, what size footing would be here.
Well, a lot of your practical application with engineering is not going to use logarithms. A lot of your logarithms are used in a lot of research and a lot of sciences. Bioengineering, anything having to do with extremely big numbers and extremely large numbers. A lot of your physics does logarithms. But the reason we learn the properties is not because that you're going to be doing a logarithm when you get out of engineering school. That's not it. The reason you're doing logarithms like this is to manipulate an equation, to be able to change it, to be able to move it, to be able to reorganize it, to get another to get the answer. That's why you're learning it. That's all this is manipulation. That's what it's for. For you to be able to take an equation, to be able to turn it inside out, to be able to fix it to where you can get an answer. Huh? Yeah, pretty much. Now, with an algebraic equation, what have you always been taught to do? Get the x's on what? One side and get the numbers on the other side. No, not on the right or left. I despise a teacher that says, you got to put the x on the left. No, you do not. That's like saying Jody has to sit on the left of the seesaw and Susie has to sit on the right. So if Jody and Susie go to a park in Anderson, and Jody sits on this side of the seesaw, and Susie sits on this side of the seesaw, and when they go to Spartanburg, when they go to a park in Spartanburg, that Jody has to sit on the left-hand side of that seesaw, and Susie has to sit on this side. And that's why I despise when you go with the smallest bucket. Which one's smaller? Okay, where is the x? Well, here's an x, and here's an x. Which one's smaller? This one is smaller, so you're going to move it. Now, this one works out to where this one is moved on the left. But if this was a negative 3x, I'd move it on the right. Because you want the smallest bucket. You want to move the smallest bucket. This one is smaller, so you're going to move it over here. Okay? And that's going to be 3x log of 2 plus x log of 2. Is equal to, and what are you going to bring this over? You're going to bring this over here because these are numbers. This is log of 2. You do that in your calculator. You do this in your calculator. So these are numbers. So bring this over, so that'd be minus. So 4 log of 3 minus log of 2.
How do we get an x log of 2?
Unless okay, I just rewrote it. That's all right. I don't know where I got that. Okay. I don't know where I got that log of 2. Now over here you can do your calculations with your calculator to get some kind of decimal here. This one is supposed to be the same. You sure I wrote it down right? Make sure. Okay. For some reason I was having brain bullets. Okay. Now, work with that equation right there and see what you can do with it. Think a little bit. I'll give you a hint. The right-hand side you can do on your calculator. Ask yourself also what you did in algebra. If something was in common, what did you do with it? X squared plus x is equal to 4. What did you do with that x squared plus x? If something was in common. So what do you do if something's in common? Factor it what?
Out.
Factor it out. And since x is what you're looking for, you factor it out. Now what do you do to undo multiplying by all that stuff?
Divide that stuff by that.
Divide all. Now somebody crank that through your calculator, and that's what x is equal to. So that would be, take your handy dandy calculator. I'm going to try it right now. Hold on. Parentheses, 4 times log of 3, close parentheses, minus log 2, close parentheses, equals. Alright, stove, and I'm going to call it alpha, and I'm going to say, that's the numerator, so I'm going to call it n. Okay, the bottom would be parentheses, 3 log 2, close parenthesis, plus log of 3, close parenthesis, I don't think it's going to like it. Okay. And I put that in the denominator, stove, alpha, denominator. And then what I do, take the numerator and divide it by the what? Alpha n divided by alpha d. I got 1.16. What'd y'all get? $1.16. There was a class that you used to take at Clemson. I took it, Clemson, and you took it before you went into your engineering. It's called Engineering 101, and it was nothing but a calculator course. And you had to do these unbelievable multi-step equations. That was the test. It was a 1-hour course. I don't know if they still teach it. I think they still teach something like it. I think it's 2 hours. and you have to take it before you go into engineering. And it was awful. I mean, you would sit there and the exam would be like 10 questions. And the steps, there was like 15 sets of parentheses and brackets. I mean, it was unbelievable. And I don't want to ever take that class again. I took it, but it was awful. I mean, statics was nothing compared to how difficult it was to do those parentheses. And back then, you had the HP 48 and the HP 49 or 48 GS, and they would not even let a TI on campus. You could not even use a TI. They smirked it. And then they turned around, and now TI is the only thing you use on Clemson's campus. So, I don't know, go figure. Anyway, so this is a small equation compared to what you can run into. All right, let's do a nerd. I was going to find another one. Let's find, all right, look at that one. I'll blow it up for you.
Who was the person who told you Clemson was
ESPN. You never watched a football game on ESPN? What do they call Clemson? Clemson. They sound very retarded. But they will not pronounce the P because they will be a redneck if they do that. They'll be a southern racist redneck. Dumb southern racist redneck if they say Clemson. So they go out of their way to say Clemson. And that's the way they say it. You ever watch ESPN? Watch it. Next time they say they have a Clemson game on ESPN and everybody goes crazy and they have it down on Bowman Field, watch it and they'll say, here we are in Clemson, South Carolina.
I should record it and like play it over and over and
You should.
post it on your YouTube video.
Yeah, you should.
Watch it.
Here we are in Clemson, Clemson, Clemson. Do they not do it? Anybody watch it? They do. They do put emphasis on the Z, the S, so they won't sound like a dumb racist southern redneck.
Are you talking about when they were at game day? Yeah, I was there and they started recording.
Yeah. Clemson. Clemson. We're in Clemson, South Carolina. All right. You know, the first thing I would do when I see this, same base. What would you do with the same base?
Just set up the very.
No, you're wrong. We're just going to live in a ditch. Same base, you rewrite it using what rule? Starts with a Q. The only one that starts with a Q. Quotient rule. Yeah, that one. That there when you put the clamp line. I forgot how to do it. All right, there it is. Oh, sorry. Now that I've given y'all a suggestion, what did he come out with? Log base 3 of what? Huh? X plus 6 over now what do you do when the bases are the same and they're set equal to each other? Set the X is what? Not equal to 0, but equal to what? Each other. Set them equal to each other. So if you have the same base and they're equal to each other, then this is equal to this. So x plus 6 over x plus 2 is equal to x. Multiply both sides by what? Anytime you want to clear a fraction, you multiply both sides by the denominator. So multiply both sides by x plus 2. And then you get x plus 6, x squared, x times x, and x times 2. Now finish. Because from here down, there's nothing but what? Algebra. You're going to find that out a lot in Calculus 1 also. 90% of your first couple of tests is algebra. Question, am I going to move the x squared to the left-hand side like I'm supposed to? No, because it ain't broke. If it ain't broke, don't fix it. Why is this not broke? It's positive. Leave it alone. So bring this across the river and bring this across the river. And that'll give you 0 is equal to x squared plus 2x minus x. And 6 across the river is minus 6. So we're going to have a 2 and a 3. So x squared plus x minus x. Minus 6, sorry. This means we've got to have a positive, so the 3 has got to be what? Positive. This means like or unlike. And what's unlike from positive? So 0 is equal to x minus 2, and 0 is equal to x plus 3. X is equal to positive 2. X is equal to negative 3. Chances are your answer is positive 2, because what? You can't take the log of a what? a negative, and you plug in -3 right there, you can take the log of 3, you can put it in the change base formula, which would be log base 10 of negative, whatever, 3 over log of 3. The log base 10 will give you an error, or an error, depending on where you're from. OIL. Well done. And it doesn't matter if you get an error in your numerator. I don't care what you divide into it, you're not going to get a number. You're going to get another what? Error. Yeah. So our answer is dang old 2. So plug it in if you want to check it. So 2, that's 8 over what? 4. Log of 8 over 4, log base 8. Log base 3 of 8 over 4 is what? 2. Equals log base 3 of what? Does that check? Now, you could do it without the algebra. You just have to substitute a bunch of numbers in here. Find out which one's equal. If you want to. A lot of what you're doing right now in this unit and what you're going to be doing the first 2 is manipulation by algebra. That's what you're going to be doing.
Section 3.5 and 3.6, that's really long.
Is that complete and square? It is? Well, if it's long, if it took a long time on the what you call it, then that means you need more practice. Just saying. All right, let's do a nerding so you can feel good about yourself. So you won't have to put smokestacks on your truck. All right, try that one. This one, you're going to do something different. It's not going to be like the first one or the second one. Yes, you're going to use the product rule. That's true. But after you use the product rule, you're going to use something else that's different. It's in your notes. It's one of those things I told you to memorize at the beginning of the logarithmic section. So if you use the product rule, you're going to get log base 10 of what? All that mess done what? What's that mean? Multiply. So using the product rule, of logarithms, that's going to give us log base 10. Now, why is it base 10? It's understood why. Because nothing is what? There. Nothing is there. So it's like a square root on an index on a radical. If there's nothing in front of the radical, it's assumed to be a 2. If there's nothing on an LOG, then it's assumed to be a 10. I told y'all that. 3x plus 2 times x minus 1, no more Smiths in the class, equals 1. Okay, now what? Yeah, use your FOIL, pronounce it however you'd like. Now you can't distribute that LOG across it. Can't do that. You can distribute the log of a number across something because that's a number. But that ain't a log of a number, that's a log of a variable. You can't, but you can use your FOIL method. That's still just going to give you a bigger variable than you had put up there, but three x squared minus x, help me out, minus 2. Okay, now what? Now we go to algebra, now what? Quit. So we put it around and pop it against another. Nope, can't do it. Huh? I can't hear you. All I've heard is boo boo boo. Do y'all know what enunciate means? Change base formula? No, but that's a good guess. But you don't use the change base formula if you have LOG base 10 because you can use that on the calculator. The only time you use change base is when it's log base 3, log base 2, log base 8, log base 15, log base whatever. That's, the change base formula is used whenever you have like log base 3. Anybody else got a guess? What's the first thing I told you to memorize about logarithm?
Y equals log dx.
What else is that called? For what of logarithm? Definition, whoever said that. Definition of a logarithm. Definition of a logarithm, write it down. If you don't know how to write it down, that means you didn't what? You didn't learn it. So no wonder you're having trouble. So in other words, you suck. And you can't write it down. Yes, sir.
Change that 1 to log 10.
You could change it to log base 10 of 10. You could do that. And that's equal to 1. Not going to help you very much. You could say, well, you could set them equal to each other then, but I don't know if that would give you the correct answer. What they want you to do is go with the definition of a logarithm, which says y is equal to log base a of what? X. And that's x is equal to a to the what? Y. So, which it will turn out to be the same thing that you're saying if you did that. Because you're going to get a to the y, what's a? 10 to the what? 10 to the what? 1 is equal to x, which is 3x squared minus x minus 2. So that's what you're going to get. Now that was very smart, what you just said. You could change this into log base 10 of 10. Are these two the same? So you can set this, you can set this equal to this, and that is this. And you could do that. So finish it. That should be simple enough. That's dang old algebra 2. I told you you should have quit. Like I say, no fun, you don't want to keep trying and keep improving yourself. It's easier to do it.
Yeah, it's easier to have a nice little red dot, you know,
No,
with a smokestack.
yeah, you don't, yeah, I need smokestacks on mine, is what I need. There you go.
Who's too afraid to race?
Some people don't even know what smokestacks were originally used for. Why do smokestacks, why do people on 18-wheelers, which is it, have smokestacks on their truck? At red lights, during the, before they made smokestacks go up to the top, the old trucks in the 40s and 50s had the exhaust coming out just like a regular car. And those big trucks were sitting so high that the exhaust would come out into the, and we didn't have air conditioning and everything, so people would like to be breathing in all the diesel out of the big trucks. That was the only purpose for smokestacks. Now you got them on these pickup trucks. The only reason that they're on the pickup trucks is because the person driving it has some insecurities, evidently, because there is no reason for it to be on a pickup truck. None whatsoever. None. There's no horsepower. That's a bunch of bullcrap. There's no reason for a smokestack to be in a pickup. No reason. So I hate to put a burst in your bubble, but there's no reason.
Everything I wanted. They don't want to get wound up.
The only thing that matters there is the intake. Now I can understand having intake above the roof then, because the intake, as long as the intake can breathe, your engine can breathe. But the exhaust, if you're going fast enough, you shouldn't be bogging down because your exhaust has got water in it. There's no reason for it. I'm sorry. -2 minus 10 is -12 is equal to 0. You have the same thing with somebody driving a $500 car with $10,000 rims on it. You ever seen that before? Or somebody driving around a $1,000 car with $10,000 worth of video equipment inside the car.
Video equipment.
Yeah, TV monitors and driving around and their engine is blowing out blue smoke because it needs to be rebuilt. But they got plenty of VCRs and TVs in their car. Whatever. Okay? And what does that come out to be? 3x, and let's see, 12 can be 3 and 4. No.
6 and 2.
You're going to have to use, you're going to have 6 and 2. 6. Yeah, 6 and 2 will work.
So either multiply 8 times
No, 6 and 2 will give you 0. I don't think you'll have to use the quadratic, not the quadratic, complete the square. Unless you just want to depend on the calculator. 3x squared minus x minus 12. 3x squared minus x minus 12. (3x squared minus x plus blank is equal to 12 plus blank. Back out 3x squared minus 1/3 x plus blank is equal to 12 plus 3 times blank. 1/3 divided by 2 is 1/6. 1/6 is what? 1/36? Y'all check me. And then that's going to be 3 times 1 minus, or x minus 1/6. Quantity squared is equal to, that'll go to 12. 1/12 right there, right? 3 will go in there 12 times, so that's 144. This, I think we've done this before. 144 over 12 plus 1 over 12. Why do I feel like we've done this before? I'm gonna check the notes. I know we've done it before. And that's gonna give you 3, that'll be x minus 1/6. Quantity squared is equal to 145 over 36. Take the square root of both sides. X minus 1/6 is equal to 145 is 12.1 over 36 is 6. 12.1 divided by 6. And bring the 1 over, so that's 12.1 plus 1 over 6. Why did I use the plus? Why didn't I use the negative? Because you can't take the log of a negative. That's what I'm assuming. So 12 plus 1 is 13 over 6. And 13 over 6 comes out to be what? 2.2. So I think your answer is probably going to be around 2.2. Did y'all could do it any other way?
Wouldn't that be plus or minus into 3?
Yeah, but why didn't I use the minus? Can't take the next, the log of the negative. So let's see what they got. We've done this before. Somebody look in your notes. Right quick. That's my wrong. Sorry. Sorry. Did y'all look? Have we done that one before?
I didn't see it.
I swear we've done
You talking about the problem?
The problem, 3x squared minus x minus 12 is equal to 0.
I have not done.
We've done it. Y'all can see how crazy I am and see if I'm crazy or not. Let's see what they got. Is that the one we just did?
Yeah.
Somebody take 1, take the square root of 145, add it together and divide by 6. Tell me what you get.
2.2.
Huh?
2.2.
It's a miracle. I did that whole problem and didn't use a calculator. Reckon I'm just that smart, or reckon it's just that easy?
You are very smart.
Shut up! You're not supposed to think that quick. No, did y'all check it for real? Is it 1 plus, did y'all check it?
I got 2.183.
I'm sorry. 2.18 and I got 2.2. I'm sorry. The whole point is I did it without a calculator. It can be done.
What is that sassy lady look you do?
I didn't know I did. I didn't know I did that.
You do it.
What else was that?
I don't know. I tell my students in the class before, I told them to get their calculators out. But the reason you use complete and square is so you won't have to use a calculator so dependently.
I just thought everybody like the story.
No. Oh, well, yeah. When you give somebody 6 cents at a cash register and they sit there and look at it and go, what's this for? That's exactly why I don't like calculators, because that's somebody that's dependent. You give somebody, let's say you go to Arby's and your bill is $5.56. okay? And you ring up $20, they ring up $20, or they ring up the bill. You give them $20, and they go, $20, ding, 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 and you say, wait a minute, I got 56 cents. And you give them 56 cents, and they sit there and go like this. Then you have just met.
You make that $10 back. You know what you should say?
You have just
Give me
met
$18
a
back.
dependent person on a calculator who cannot do SA mathematics. $20.56 minus $5.56 is what? $15. But you would be surprised how many people could not do that. Now, I do not have a problem with you finding the logarithm of something on a calculator, because unless you're Rain Man, you're not going to be able to do that in your head. But doing completing the square versus quadratic formula, when you do quadratic formula, what are you depending on? You depend on the calculator to do the work for you. When you do quadratic complete the square, you're depending on your basic mathematical skills to do it. That's why people don't teach it, because they don't want to have to repeat how to factor out a 3 when the middle term is a 1. That teacher, that high school teacher, don't want to teach you that because you didn't learn it to begin with. So I think it's very important that when you do a mathematical problem, that you know how to do both ways. And if you know how to do both ways, check it with the calculator, use the calculator all you want to. But don't regurgitate what that calculator puts out and have no earthly idea what you just did. That's what I don't do. I love the calculator. I don't use it very much. But that's your answer. Did y'all check it to 1.83, I think you said, or 2 point whatever is 200ths off from what I said? No story, but you ever been to, I know y'all been to Charleston, Chucktown before, but there's a place down there between Chucktown and Georgetown. It's called Seaweed.
Yeah.
Seaweed? Okay, that's where it happened. I took at that time it was my wife and 2 kids, and we went there, and the bill was, we ate, and it was really nice, good place to eat. And the bill was like $78, $90 or whatever. And it was somewhere in there. And it was 78, and it was some change. 57 cents, and that's why I use 56 cents all the time. And it was 56 cents, and I gave her a $100 bill, and I gave her like 56 cents. And she just sat there and looked at me like she thought it was a tip. And I said, "You gonna give my change back?" And she was like, "I don't know what to give you back." And I said, "Let me speak to you, manager." And I said, "I hope you're not losing money." I said, "Because she can't do simple math." I said, "I would get her off the register if I was you." And I'm sorry, but a man that owns a business, or a person, man or woman that owns a business, should not have a person on a cash register that cannot do simple math. Shouldn't. And if you're one of those people, keep your mouth shut, don't say nothing. Just learn how to do simple math. Or you're going to end up owing somebody, what? A lot of money. Because your cash register is not going to come out, what? Right. Because you don't know how to make change. Nobody gonna say anything.
The water tastes like salt.
Don't drink the water in the Low Country. Period. Ugh. Oh my gosh. Let's not even. Let's do this one, because y'all will make sure you quit on this one. Aren't y'all impressed how I learned how to do this? Y'all, I think y'all taught me, or one of my classes taught me. It sure does save me a lot of time. Look, I made her mad. She's leaving. All right, work on that one for a second. Now remember, if you get confused, change ln to log base what? You're a disgrace and a disappointment. Log base e. And then you could use your LOG rules just as well as you can use the natural log and LOG rules are the same. But some people don't like to use natural log. Like me, I like to use LOG because that's the way I learned it. So I'm going to change these to LOG base E and then see what we can do. So take a minute and do that. If you want to leave it as natural log, that's fine. I need to call the roll so y'all can run out of here like a bat out of Hades. I think Wednesday we're going to have to order some pizza. Y'all going to have to remind me. I know y'all not going to bring anything to eat, so I know we'll go ahead and order it. I ain't had any good pizza in a while. I finally got to watch dang old Mockingjay, dang old part 1. Finally got to watch that this weekend. I liked it. I liked it better than some of the other ones. Nobody's going to talk about it. What?
I said you are crazy.
Why?
There's no way that Mockingjay was better than the first one. Definitely on the second.
I liked it because...
I'll give you that it was good, but it definitely wasn't the best out of it.
Well, you know why I didn't like the first one? I couldn't tell what was going on because of all the camera going all over the place. I couldn't. The fight scenes were just so Yeah, that's it. That's what I was doing. I was trying to figure out the math. That's it. That's what I was trying to do. All right, math 110. Okay, Miss Anderson is here. Barron came by. Borth is here. Crane and Crenshaw, not here. DeVore, Evans is here. Fisher, Hall, Keller is here. Lou is not here. Lou, I'm worried about Mr. Lou. He hadn't missed. He's missed a couple of days.
Probably fell down in a ditch somewhere.
Yeah, he is. He lives in the ditch. Moore. Mary Moore, Nix, Pace, I saw Mr. Pace right before class, Page, Pahela is here, Pruitt's here, Sab is here, Sloger is here. Miss Sloger, you need to quieten down, you're too loud. Stone, Walton, as in John Boy. Woods. Okay. You need to quieten down too, Mr. Woods. You're distracting people. Okay, we got that done. All right, y'all ready? All right, look what happens. LOG base E, natural log of X. I'm sorry, base E is E. Let me redo that. Minus log base E, X minus 3. Equals log basically, now all I did, was change. I changed that guy into that guy into that, and that guy into that. That's all I did. Now look what we have here. What's log base E of E? 1. And 1 to the natural log of x is natural log of x. Then you can change that back to log base E of x. You can do log base E of x minus 3 equals log base E of 2. And I'm going to change this back to log. I'm just going to do it in red. Log base E of x. Now tell me what I can do with this guy. Quotient rule, good. Now, if you're starting to pick up on that, then you're starting to learn how to manipulate. You're starting to learn. You see this, and you go same base. Okay, we can go log base E of x over x minus 3 is equal to log base E of what? 2. Now what?
Give up.
That's it. Live in the ditch. Set them equal what?
Each other.
To each other. So x over x minus 3 is equal to 2. Finish it. So I'm going to multiply both sides by x minus 3. And that's going to give me x is equal to 2x minus 6. And I'm going to bring this x over here. Bring that 6 over here. And check me. And you can plug it back into your answer. Let's go ahead and see that. This is going to be natural log of 3. Natural log of e to the natural log of x. So natural log of what? I'm sorry, 6. So somebody take e to the natural log of 6 and take the natural log of that minus the natural log and see if you get the same as the natural log of 2. You probably will. Or we can just check the book and see what they got. See if they got 6. Of course they did. There it is, right there. All right, look at that one.
So is E
Oh my.
is E equal to 1?
E is equal to like 2.17. Get it on the calculator. E equals. Try this one. E to the 2x minus 4e to the x plus 3 is equal to 0. Yeah, I'm fixing to take it out. And of course, I'm not thinking we're going to do it. I'm thinking we're going to quit, probably. That's what I was hoping. Where did my do jigger go? Well, I'm darn. Mr. No, what's it called? Snip.
Step.
Really? EX.
Huh? 4e to the x. There you go. Now, anytime you've got something that looks somewhat like a quadratic, which this does look like a quadratic because of the way it's written, and it said, I even think it said quadratic in the directions. You need to figure out what's the relationship with this and the quadratic form, not the quadratic formula. Quadratic form, which is ax squared plus bx plus c is equal to 0. This is raised to the second power, and this is raised to the what? First power. So, you could say that this could be e to the x raised to the second power minus 4e to the x plus 3 is equal to 0, couldn't it? Yes or no? Can I rewrite that like that? You're supposed to all say yes, sir. Yes.
Yes, sir.
Yes, sir. Yes, sir. So I could easily say that u is equal to e to the x. Therefore, I've got u squared minus 4u plus 3 is equal to 0. Now, this is what we call, from here to here, U substitution. Do you think this is the first and last time you're going to hear that? No. You're going to hear this in Calc 1 and 2. Except it's going to be used with antiderivatives, which is the area under the curve.
You teach Calc 1 and 2?
No, it's got to make it. Now, what can you do with this? Y'all ain't never heard that before? You don't like to be somewhere, you just say, I ain't never lost anything with it before. Or I ain't never lost anything in the real world, or I ain't never lost anything in California. I was just out there for a year, I ain't lost anything. Alright, so what can you do? Reverse FOIL maybe? Thing on 1 and 3. Thing on negative and negative. So, what is u equal to here? And what is u equal to here? So now, what is U? Got it right here. U is equal to e to the x. So what am I going to do here? Thank you. E to the x is equal to 1, and e to the x is equal to 3. Keep working. This will be the one we finish on today, so hurry up and finish. Now I'm going to show you a trick I learned in the war. E to the x is equal to 1, and e to the x is equal to 3. Now this little trick is something that you're going to use in differential equations a lot. A lot. And that is, when you take the natural log of both sides, and write this down. Let's just write it. Let's do this. I want you to write it down because I want you to remember. Natural log of e to the x is equal to x. And you can prove that by changing natural log to what? What's log base e of e? And what's 1 to the x power? X. 1 to the x. You're thinking anything to the 1 power. 1 to the x power x. So that's where that comes from. This is very important because now I can take the natural log of both sides and what happens here? The natural log of e goes off and you're left with x. And the natural log of 1 is 0. And over here, you just do x is equal to natural log of 3. You can do it as log as e of 3 equal to. And you can change that to log of 3 over log of e. Do it that way. You might take the log of 3, natural log of 3 in your calculator and see what you get. I don't know if they did that or not. Let's see what they did. No, they just left it. I love this part. Look right here. E to the x is equal to 3, and then they just drop down and they say natural log of x is equal to natural log of 3. Do they tell you why? Nope. The reason they don't is that you're supposed to be able to get it right there. Remember this. If you want to get rid of this right here, the if you wanna get rid of e to the x and just get x, take the natural log of both sides.
Is this right?
Or log base e of both sides.
Is that how you're talking?
Log base e is e. No. Take the natural log of it.
You want the camera off?
Natural, yes, please. Natural log of
Cam, hold on,
the.
I need it for a reason.
One. Right, you have to go to work. That's the way you do it. Natural log. These are the ones you
I did,
These are the ones.
yeah,
No.
it told me what you was.
Yeah. Well, you can, so log, natural log of subtraction p to the first pile, square parentheses, square parentheses equals. You can't do log base e in your calculator. You have to change it to, if you did this, look, you can't do this in your calculator. You can here, but if you want to do this, you have to do this. Log of 3 over the log, do log of 3 over the log of 8, and you'll get the same answer.
So
Yes,
it
ma'am.
would come up
On the
there.
test, the one that's due tonight,
Uh-huh.
I did the completing
You
square
wrote me an
questions.
email about something.
No, that was about the homework.
Okay.
The one that the test, I've already taken it. But
Uh-huh.
all the completing the square questions, I put them in decimal point, but it's the right answer. It's just you wanted it.
You want me to
in
fix it?
fraction. Yeah, if you could.